There you go.
Okay, does that look as though it's in focus for everybody?
Yes.
Okay. Firstly, let me say thank you very much for inviting me. One of the things that Southern Oregon Climate Action Now has been trying to do for some time, we just haven't got around to it. Can you hear me?
Not very well.
Not very well.
Do we have a microphone or not?
We don't. I don't know how to set it up.
Maybe just stand closer to us.
How about if I stand a little closer to the middle of the crowd? Is that going to work for you, Doug, or not?
That's fine. May I suggest you remove your jacket?
I'm about to do that. Yeah. Make myself comfortable.
Now that voice is good.
Well, I'll try. Okay, I'll try and shout. And if you can't hear me, please shout at me and tell me you can't hear, and I'll do the best I can. What you can see is Doug here is the videographer, so this presentation, with a bit of luck, will actually be on our website as a video presentation in the not too distant future. Kathleen suggested that I work for, but I really don't. I'm a volunteer with Southern Oregon Climate Action Now, just as I'm a volunteer teaching a course with Ollie at SOU. So I'm not getting paid for any of this neat stuff that I do. So if you think, follow the money, that's why he's asked.
Wait a minute, they gave you a free T-shirt.
Actually, no, I paid $10. And I got 3 of them. People say to me, well, you're always wearing the same shirt. No, I got 3 of them. Okay, so what I'm going to do is talk to you a little about the problem of climate trends and projections in the Rogue Valley. And here you can see it was put together specially for you. What I want to do is start with a few images just depicting what the patterns are that we are looking at. One of the nice things that's just recently happened is that the Medford Mail Tribune is starting to connect the dots. I've been kind of beefing at them for a long time. So these are the kinds of things that we are seeing happening in the immediate area. If you've been down to Shasta Lake recently, you will notice there's not a lot of water in it. Same thing is true in Oroville Lake, which is just a little further down on 99. This is Oroville Lake. You can see that's in what it should look like, 2011, and this is in 2014. And you can see the problem. I've got 2 or 3 shots here that illustrate the problem. I wonder if we should turn the side lights off. Would that be better?
Yeah.
Are you guys okay? You can see all right? Tell me. It's good? It's okay. Okay, I think most of the slides are going to be a bit brighter than this. Again, and what you can see is these are the same places. You can see what's happening. There's not too much water in Oroville Lake. Now, if you go a little further east in Oregon, over to Heart Lake, there's a pronghorn or an antelope refuge. They're really pronghorn, but I'm a biologist. I get picky about that stuff. This is Heart Lake, sort of historical images. Kathy and I were over there last summer, and it looks like this. That's what Heart Lake looks like now. Find a spot of water in there, and you're in luck. I took this photograph. Kathy and I happened to be driving down I-5 the day the fire started, and we snagged this shot back in July 2013. That's the same angle. We were just coming down past Wolf Creek, and we saw all this smoke coming up, and I said, I want to take a photograph of that. So we just stopped, and I took one out of the side of the car. That one comes from the Mail Tribune. I snagged that from the Mail Tribune. And that's illustrating one of the Forest Service aircraft that's spraying the fire. And if you recall, there were quite a lot of wildfires right about that time. And the next one shows a satellite. I think it's a satellite image. And you can see the smoke, August the 7th, 2013. Everybody remembers that, right?
Yes.
In fact, some of us who have a respiratory problem were having difficulty breathing right about there. Funnily enough, Kathy and I left the state. We were visiting a daughter in Colorado, so we missed the worst of it. One of the things I try to do when I'm doing presentations is I tell you where I get the images. And so what you can see along the bottom here is the source of these images. There's nothing that I'm going to show you that's a secret. It's all public knowledge. Anybody can find it. I just happen to know where to look. What we're looking at here is a map of Oregon, March the 3rd. So this is the most recent map of Oregon's drought arrangement. And you can't see the writing here, I suspect, but those are various degrees of drought, from abnormally dry through extreme drought. And you can see much of Oregon is in the condition of extreme drought, and the dark red is exceptional drought. Last summer, by about July, I'm getting the finger to move back. If you lose me, shout at me and I'll shout a bit louder. And I'll trip over the wires as well. About last July, 9 counties in Oregon had been declared drought emergency areas. This is the short-term future in terms of temperature and precipitation. And you can see this comes from NOAA. It's not some wild pinko outfit, pretty reputable outfit. And you can see the projections for 90 days temperature are for above normal temperature and below normal precipitation. So that's where we are right now. And a few headlines from the Medford Mail Tribune. You might remember this one. This is way back. Mount Ashland ski area gears up for heavy winter. Mount Ashland area remains closed. Catastrophic wildfires expected in southern Oregon this summer. And this is the one I really like. I was just about to send the Mail Tribune a note complaining about the fact that they were talking about all these weather phenomena and they weren't connecting the dots. If you saw this one, you'll see they actually mentioned global warming. So somebody is connecting the dots. This is Steve Fry from Fry Family Farms, incidentally. Okay. Now, I wonder if I can move this forward a little, and we'll see if we can get the whole screen on the screen.
You have to move it back.
Well, no, moving it back is going to make it bigger. Actually, but I can't move it forward, so I'm sorry, because I'm going to pull it out of its socket. So we'll do the best we can. Okay, I do this presentation for high school groups, and you know what happens when you're in high school. Kids just want a nap. So I do this so that if the teacher comes up to them at the end of the presentation and prods them on the shoulder and say, "What was that about?" they can answer the question. So I'm going to let the cat out of the bag. The messages in my presentation are as follows. Climate change consequences are here and now. A lot of times you will hear people talking about global warming, climate change as though, well, that's a problem in the future for those people over there. No, it's here and now. We are living global warming as we speak. And the projections as we look into the future are no more than a continuation of the trends that we are seeing now. And all of those things that I was showing you just a moment ago are the trends that we're seeing now. So I'm going to show you data which are based on the history. So these are actual data. And I'm going to show you some projections into the future which are based on models telling us what the future is going to look like. Now, I didn't include in this presentation, for the interests of time, a couple of slides which illustrate that the climate projection models are very accurate. And the way to test those is to run them over the past history and see how they project what we've actually seen. It's a way of testing them, and when we do that, we find the models that include human emissions of greenhouse gases are much more accurate than the models that exclude human emissions of greenhouse gases. So the models are pretty robust, and that test suggests to us that if we look at those models into the future, we're probably seeing what is likely to happen. So here are some data from Medford. Again, nothing secret. You can actually get these from the NOAA website. I happen to get them from Ryan Sandler because we were working on a project with NOAA. This is what the Medford climate temperature pattern looks like over the last 100 years. Now, if you're interested in the statistics, that is the regression line, the equation for the regression line that I put through the data. Now, I think you can see the trend is pretty clear, and what that's telling us is that's why temperature is a function of 0.0186 times the year plus 53.297, which is the equation for that line. What that's telling us is the temperature in Medford is increasing at the rate of 1.86 degrees Fahrenheit per century. That's the pattern. An interesting feature that you can see right here is one we see when we look at global patterns, and that is most of the warming has happened since around the late 70s, early 80s. If you looked at the previous period, you would not see that kind of a slope. But much of the warming has happened over the last 30 years or so. And 2014, incidentally, was way up here.
Question for you here, Alan.
Okay, thank you. If you have a question,
Oh,
I'm
no,
glad you...
what I was doing is flipping my hands to look at the curve before
Okay.
1974 and couldn't have.
Up to here and beyond here. Okay. I've done that myself.
Thank you.
I should have one of those optical things, no? What are the, how far down can you read E, O, Y? Okay, so that's the pattern you can see. These data are parallel, but these are from Rogue Basin as a whole. Same thing, this is the history. You can see again, warming has happened since around the late 1970s and early 1980s. What we're going to do here is go into the future. Those are three models representing what the temperature pattern is likely to be in the Rogue Basin as we go through the coming century. They are all based on what is called the business as usual scenario. And I'm going to be talking about scenarios a bit as we look at projections. And what scenario means is the values that are put into the models about human behavior in terms of population and what kind of energy resources we're using and how economic growth is going. These are all based on the business as usual model. What that means is we just keep doing what we've been doing, which means essentially nothing to address global warming, nothing to reduce our greenhouse gas emissions on a global scale. And not only that, but we're continuing to increase our emissions at an accelerating rate. That's what these models are based on. Three different models. One is Japanese, one is Australian, and the other is British. We don't have the US model, the data from the the Goddard Institute for Space Studies here, just because the source for this data set wasn't using the GISS data. But you can see the pattern, and I'm going to give you the numbers a couple of states into the future. The first one is 2035, 2045. So this is the average increase that we're likely to see by that, and as I do these talks, that is getting closer and closer, you'll appreciate. So we're likely to see up to a 4-degree Fahrenheit increase overall. Winter, not quite as much as summer. And if we think of August, which is the warmest month of the year, as you undoubtedly are aware, we're looking by that time at about 7.5 degrees potentially increase.
And that's the average?
That is the average for August increase. Okay, just for August. So let's go further down into the future now and look at 2075, 85. Now we can see the average is as much as 8 degrees warmer. That's the annual average. Again, looking at summer and winter, we see summer a lot warmer than winter. But again, think August. And you thought last August was a bit toasty. Imagine you're coming back in a few years and 17 degrees warmer than currently. My background, incidentally, is in ecology, and this is what got me interested in the whole area of global warming and climate change, because I realized that natural systems cannot tolerate the kinds of warming trends that we were seeing projected. And this is a kind of warming pattern that would destroy our natural systems. But not only that, if you're one of those people who doesn't give a rip about natural systems, that also will destroy our agriculture and our forestry. So we are dependent, of course, on our natural environment for our agriculture and our forestry. That kind of a temperature increase is just stunning. People call people like me, folks like me, climate alarmists. And I will tell you, as I look at the data and the projections, there is absolutely no way one can be too alarmist about this issue. No way. This is a chart. This comes from the USGS. It's a really nice site. Anybody can go there. Again, if you're interested, shoot me an email and I'll be more than happy if you can find this to point it out to you. This is Jackson County, Oregon. And what the USGS has done nicely for all of us is produce charts, as I'm going to show you, for every county in the United States. So we can go to this chart, this website, and see what the projections are. So if you've got an Uncle Bert or whatever who lives in Cleveland and wants to know what's happening there, send them to this site and they can find it. What we're looking at here are historical patterns, and these are projections. RCP 8.5 stands for Representative Concentration Pathway 8.5. That is the Intergovernmental Panel on Climate Change 2013 version of the business as usual scenario. So what you're seeing as we go through the century is exactly the kind of pattern that I was showing you for the road basin. This is for Jackson County. Up to an increase of some 2, 4, 6, 8 degrees Fahrenheit on the average. This is mean maximum, that's mean minimum, this is mean maximum temperature, exactly the same pattern. The blue line assumes we actually do something to address the problem. In other words, we reduce our carbon dioxide and greenhouse gas emissions somewhat, but still you can see an increase as we go through the century. This is the mean maximum temperature for, let's go back. This is Jackson County, mean, max, mean, min. This is the actual change, and it shows the same pattern, but because we can't see the axis, you can't see what the numbers are. But this is an increase of about 8 degrees. And this is the minimum change. This is Josephine County, for those of you who live in, anybody live in Grants Pass? So this is for you. It's the climate, remember?
Yes.
Okay, I'm always amused by that. I'm expecting there to be a comma stupid. Remember Bill Clinton, it's the economy stupid? I'm expecting to see that banner across Main Street, Grants Pass, say, it's the climate, stupid. But this is what we're expecting to see for Josephine County. Exactly the same pattern. Not surprisingly, it's not as though Josephine County is on the other side of the planet. Same thing, I'll just jump through these quickly. We're seeing the same pattern for Josephine County as for Jackson County. Sometimes we wonder about not just the averages, but those extremes, those heat waves. They're particularly critical to us as they are to other organisms. So let's look at Medford 100-degree days. How many days in the year are there over 100 degrees? Anybody take a wild ass gun? Yes?
25, 30.
25 or 30. Just feels like that. It's not quite that bad. Really bad years maybe up as 20, but this is the pattern. It's somewhere between 7 back at the beginning of the century to maybe 11 at the end of the century. So the number of days over 100 degrees is probably only about 10 a year currently. But you can see the trend, it has increased as we went through the last century. This is a set of projections into the future. So this is the recent past. Fortunately, the number here corresponds to the number that I just told you, about 10 for Oregon, Southern Oregon. But let's go through the century and see what we're likely to be experiencing, those of us who live to 2100. How many are going to be here then?
Our grandchildren will be here.
As Doug said, our grandchildren will be here. So this leads me to be able to say, when I'm talking about global warming, the subtext is, it's a question of intergenerational justice. That's what it's all about. Do we care about future generations? I'm sorry. Give me a kick if I'm standing in your way. So this is the lower emissions scenario, probably equivalent to that RCP 4.5 I just showed you. So coming down into the Bear Creek Valley, you can see a little darker, what, maybe 30, something like that. But let's look at the business as usual. You look at the whole country and you can see the trend. But where we are, just a bit darker, maybe 45 days over 100 degrees. So those of you who are guessing 25, 30 now, come back at the end of the century and you will be underestimating. That is if we do nothing to address the problem. Stress, if we do nothing to address the problem. But we are in control of our own destiny, and that's a key point. Temperature is one variable. Precipitation is another one that's important to us, of course. And I'm going to talk about rainfall and snowfall. Just overall precipitation, this is the pattern, observed U.S. precipitation pattern over the last 50 or so years. You can see quite an amount of variability around the country. Green means more precipitation, brownish, yellowish brownish means less. You can see where we are, probably not much change, maybe a slight increase in precipitation, but not much. Nationally, we have seen an increase in precipitation of about 5%. Substantial regional differences. Now let's look at Medford. Actual data from NOAA for Medford. Now, I put a line through that data set. One of the things about this technique called regression analysis, statistical analysis, is it will put a line through any data set. Just because it puts a line through the data set doesn't mean it's a significant slope. I did not do the statistical analysis on this, I just put the line in, but my experience with looking at millions of, well, I'm exaggerating, lots of data sets over my professional life, my inference here is that line is probably not significantly different from being a flat line. In other words, I'm suggesting that the precipitation in Medford probably has been pretty level over the last century. If we look at the USGS site, again, we see pretty much the same idea. Now we're looking at those same two scenarios into the future. The red is the business as usual scenario, the blue, we do something to address the problem. And you can see, as we go into the future, what the projections suggest to us is no change in precipitation on an average annual basis. Okay? And I didn't mention this, I should have done. If you have a question, please just shout at me because I can't see you too much. So just shout it out. As you might gather, I'm pretty informal. Now, let's look at seasonal patterns in precipitation because this is important in addition to overall averages. Actually, overall averages don't tell us as much as we need to know. This is precipitation seasonally. Okay, so we're looking at winter, spring, summer, and fall. So what we want to do is home in on Oregon. What you can see is the winter projections. This is the business as usual scenario through the century. Winter may be a slight increase in precipitation. Look at spring, and we're in the little white section, no change. But look at summer. Now, when I show people this, they say, my God, it doesn't rain much during summer now. What the hell? Well, Exactly. We don't get a lot of precipitation now during the summer, but as we go through the century, the probability is we're going to get less. That is particularly important, of course, because that's when our farmers are growing crops. That's when they need irrigation. And then when we get back to fall, again, pretty much no change. So, although the overall annual precipitation probably isn't going to change very much, what we're going to likely see is a real shortage of precipitation exactly when we or our plants need it. There's another element to precipitation which is important, and that is when it rains, how does it rain? And you will appreciate probably if we get very light drizzle, that replenishes soil moisture. On the other hand, if we get heavy thunderstorms, what that does is simply hit the ground and cause soil erosion. It doesn't get absorbed by the soil. So heavy rainfall is not very helpful to us in terms of replenishing soil moisture. Look at the trend. This on the left-hand side is showing us we're going to get fewer of those wonderful light drizzle days, but more heavy downpours. So the rain that comes is likely to be coming in heavy downpours rather than soil replenishing light rainfall. That is a big problem. It's a trend that we have been seeing. We're simply expecting to see it continue. Is that a question?
Yes, it's
Go
a
for it.
question. In the last couple of days, they had this thing on the radio about, the lesser snowpack, but people not as worried because there was equal precipitation. But my question is, if there is equal precipitation but less snowpack, which season is actually affected the most?
I'm going to get to that. That's a good question. I'm about to get to snowfall. So if I haven't answered that question by the time we got off snowfall, shout at me again. Okay?
Fine.
So this is annual mean snow for Jackson, Oregon, mean snow for Josephine, and this is the trend. The trend that we can see is one of decreasing snowfall. The projections tell us that is going to continue. If we follow the business as usual model, you can see by the end of the century, we're looking at, in some cases, almost inconsequential snowfall, but at least somewhere down about 10% of historic patterns. Whether we're in Jackson or Josephine County, the trend is essentially the same. Let's look at some historical data. I probably should have put this one first. Since Crater Lake was invented in 1933, I think it was, they have been, not surprisingly, collecting data on snowfall because that's very important to them from a tourist point of view. So these are the actual data from Crater Lake, which I got from, I think the guy's name is Peter Grimes, or David Grimes, who is one of the resource specialists up there. You can see the pattern. It's decreasing snowfall. In fact, it's gone down about 25% during that period of time. What's that, about 70, 80 years. I happen to live across the ridge in the Applegate Valley, so I am less concerned about what's happening up at Crater Lake than what's happening in the northern Siskiyous, because that's what provides Applegate Lake and that area with water. And so I did a bit of poking around and I came up with some data which looked at Northern California Siskiyou snowpack from 1950 till 2000. Below 7,500, it's declined about 13%, 13%. But interestingly, above 7,500 feet, it actually has increased. Now, the projection is that cutoff of 7,500 feet will actually rise up in elevation. So higher elevations, even during the course of the century, are going to get less snow. What seems to be happening, and this gets to the question that was just asked, is what we're seeing is the precipitation, the clouds coming in off the ocean, blowing in up onto the Cascades. What they're doing is dumping their precipitation at lower elevations as rain rather than getting up to high elevations and cold and dumping it with snow. So what we're seeing is that precipitation falling as rain, not snow at higher elevations. Okay? That's the trend that we have seen happen, and that's what we expect to continue to happen as we go through the century. What's important about snow, unless you're a skier, I guess, is the snow water content. That's the amount of water that's in the snow. Now, if you spent any time playing snowballs, you know some snow is wetter than others. Not all snow is the same. And I guess if we were Eskimos, we'd have different words for those different kinds of snow. You probably heard, what is it, they got 300 words for snow or something like that. I don't know what it is. But that wet snow has more water, not surprising. So what we're looking at here are trends in snow water equivalent 1950 to 2002. Again, historical pattern. As we see red circles, we're looking at decreasing snow water equivalent. As we look at blue circles, it's increasing snow water equivalent. And you can see the pattern. Pretty much all red circles, few blue spots, but pretty much reducing snow water equivalent. And look at this, all the way down the Cascades. Reduced snow water equivalent. That's the history. And as you are aware, this is something that I had no idea about until I moved out west. That is, what we have done, or our forebears, maybe some of us, I don't know, is we haven't built reservoirs here because all of our summer, fall water has been nicely stored up in the snow. So what's happening is our natural reservoirs are getting less water in the snow.
When you say we haven't built reservoirs, who are you talking about?
People who live in the Pacific Northwest.
Okay.
We've built a few, but largely not as many as in other places because we didn't need to. The snow hung